So, happy Thursday, people. All right. Hope that warm up and homework check went well for you guys. I'm going to show you a little bit about 10.7, and then Miss Hamilton's going to take care of the rest again. Today, our goals are recognizing inscribed and circumscribed polygons, applying the relationship of opposite angles and quadrilaterals, and identify the characteristics of an inscribed parallelogram. Now, here's the deal. Tomorrow in class, you will be given a graded homework assignment. You will have the entire period to work on that graded homework assignment, and tomorrow you'll find out the due date of that graded homework assignment. The purpose of this is, because we haven't had a Chapter 10 quiz, all right, this is in place of the quiz, all right. We'll give you some time to work on it. We'll let you know sort of like rules as far as who you can work with and whether or not you can use a tutor to help you with that. But the purpose of these graded homework assignments is to assess what you know and not necessarily what your friends or your tutors know. Okay, so I'll just say that as a precursor. All right, but that'll come out tomorrow. You'll get that tomorrow in class. Okay, I will be back, and I will be back on Monday in class as well. So let's talk about 10.7. We just talked about our goals. Let's remember our triangles. I remember our 45, 90 triangles, where this is A, and A root 2. All right, I have my, let's go 30, 60, 90 triangle, or this is A root 3 and 2. Hey, that's from chapter 9. Don't forget it. That's not going away. Okay. In our goals, okay, recognize inscribed and circumscribed polygons. All right, there's a difference when a polygon is inscribed in the circle and circumscribed about the circle. Okay, so if it's inscribed in the circle, well, I have this circle and the vertices of my polygon rest on the circle. It's inscribed in, it's inside. All vertices are inside the circle. Okay. There's a case where it's circumscribed about the circle. All right. In that case, my vertices are all outside of my circle. And we've seen a shape like this in our warm-up. Okay, in our warm-up, we saw a triangle that was circumscribed about the circle. Okay, the vertices are all on the outside. Okay, that would be an example of that. All right. If a quadrilateral, so moving on to inscribed, if a quadrilateral is inscribed with a circle, then the opposite angles are going to be supplementary. Okay, well, that's pretty neat. Well, I know that if angle A is 109, then angle C has to be 180 minus 109. So the measure of angle C equals 71 degrees. Angle B is 72, so angle D has to be 180 minus 72. So the measure of angle D equals 108 degrees. Okay. If I have a quadrilateral inscribed in a polygon, or excuse me, inscribed in a circle, then the opposite angles are supplementary. So if I were to have equations here, let's say this was 2x and 3x plus 10, then it'd be 2x plus 3x plus 10 equals 180 degrees. All right. A quadrilateral can be inscribed in a circle if and only if the opposite angles are supplementary. So which of the following can be inscribed? Well, this here I have 68 and 122. Are these opposite angles supplementary? Well, let's think about this. If I add 8 to 122, I get 30. If I add 60 plus 30, I get 190. So this would not be allowed. Okay. Here, well, I don't know what the measure of each angle is. I have 4x plus 6x, that gives me 10x, plus x plus 5x plus 3x, so I have 18x equals 360. because it's a quadrilateral, all of the angles have to add up to 360 degrees, divided by 18, x equals 20. Well, if I plug in x, this is going to be 40. Excuse me, this is going to be 80. And this is going to be 100. So are they supplementary? Yes, this would be an example of a yes. Okay? Little story time here. Story of the plain old parallelogram. All right? I want you to think about this little plain old parallelogram here. So once upon a time, there was this plain old parallelogram named rectangle. Rex was always trying to fit into a circle, that is. One day, Rex awoke. He awoke, and he found out that he had straightened himself out, and finally he had inscribed himself. What did the plain old parallelogram turn into? Oh! A rectangle. Okay, turned into a rectangle. Isn't that neat? Wow. I could tell that story 1,000 times. 1,000. That's a lot. Yes, that's a lot. But we're just going to go with it. All right. So anytime a parallelogram, specifically a parallelogram, all right, anytime a parallelogram is inscribed in a circle, then it has to be a rectangle. So if a parallelogram ABCD is inscribed in a circle, then what does it have to be? Oh, it must be a rectangle. So let's draw this figure. I'm going to draw my rectangle. That's pretty bad, but we're just going to go with it. Okay, we're going to go with it. Okay, it says draw a rectangle and its diagonals intersect at E. Oh, buckets, there's one. There's another one. So this point is E. Okay, draw the figure, check. Oh boy. What is true about ABCD? Well, what do we know? It's a rectangle. It's a rectangle. What would BD be considered? Well, if it starts at one point on the circle and goes through to another point, and then E is the center of my circle, what is true about it? It's the diameter. A segment that connects 2 points on the circle and goes through the center is called the diameter. So if we looked at this problem and these things were true, where AB is 5, BC is 6, find AC, well, I have what type of shape here? This is a rectangle, then this is a right angle, so I have a right triangle. 5, 6, right angle, X. How do we do that? Well, you guessed it, Pythagorean theorem. So pause the video, do the Pythagorean theorem, go. Hopefully you actually pause that. Okay. So let's look at this. 5 squared plus 6 squared equals x squared. I knew that x was my c value because it was opposite of the right angle. 25 plus 36 is 61. Square root both sides. I get x equals the square root of 61. Okay. These next two, Miss Hamilton is going to take you through. All right, so good luck with that. Good luck, Miss Hamilton. Go get them. All right. Enjoy the rest of your day. Enjoy today. Enjoy tomorrow. Have a great day. Okay, goodbye.